Bismillahirrahmanirrahim. Measurement and instrumentation. So, instrumentation measurements is it's the name of our subject. It's a very interesting subject. You may learn a lot of things that is associated with your daily life in this course. So, it's the first lecture. So, let's start with the introduction of the instrumentation and measurement. So it's a brief content of this course, and we have to cover the following topics in this subject. So we will start with the definition of the measurement and the instrumentation. Then we will move on to the types of the measurement, the types of the instruments in measurement, and the review in the top and the units of measurement, standard of measurement, calibration, and the application. Okay, these are the content of this first lecture only. Okay, it's not the content of the full course. So the complete course breakdown has been uploaded in the portal, so you may find it over there. Okay, so uh, let's move on. Okay, definition of measurement: a method to obtain information regarding the physical values of the variable. Okay, so this is the definition. The method which is obtained to, to obtain information regarding the physical quantity. Okay, so what are the physical quantities? uh, the thing which is to be measurable. So these are, for example, temperature. Okay, it's a measurable quantity. So we can say it's a physical quantity. Okay, so temperature, weight, okay, and time, length. Okay, so these are all the physical values. Okay, so for these are the physical variables. So for these we have to obtain some information. So the method of obtaining the information regarding these physical quantities is called the measurement. Okay, so and what are the instrumentation? The devices which are used for obtaining these information regarding their measurement is called the device. Okay, so for example, for this physical quantity we will use thermometer. Okay, so thermometer is the instrument, and the information we will obtain from this thermometer is, for example, 70. Okay, you know what is the normal body temperature? 98 degree Fahrenheit. So this is the information which we have gathered about this physical quantity using this. Okay, so these two are associated with each other, so that is why both of these are having a combined subject for the instrumentation and measurement, because these two are associated with each other. Okay, we cannot separate and isolate these two from each other. So that is why the subject is named as uh, instrumentation and measurement, or measurement and instrumentation, both are the same thing. Okay, so for the weight we will gather the information, for example, 10 kg. Okay, and 10 kg we will get this information using an instrument called the scale or the balance. Okay, weight machine. Okay, so all these are instrument used to gather information. Okay, for the time. Okay, the stopwatch or the clock, etc. Okay, length, foot, uh, okay, scale, and ruler. We call it ruler, not the foot. Okay, okay. Terminologies. Physical quantity, as I have already mentioned, that these are the variables. For example, the pressure, the temperature, the mass, the length, time, the light intensity, etc. These are the physical quantities. And data, the information obtained from the instrumentation or the measurement system as a result of the measurement made of the physical quantities. Okay, so the information which you will get after measuring the physical quantities, these are called the data. And data that has a calibrated numeric relation to the physical quantities, so these are called the information of these instrumentation. Okay, and parameters, the numeric limits are the parameters or the unit, we can say. Okay, for example, degree Fahrenheit, degree Celsius, or Kelvin. Similarly, kilogram, gram, milligram, etc. Okay, and for the distance, the meter, the kilometer, and the centimeter, etc. Okay. Okay. So, what is the purpose of measurement system? So, it is very easy. We can see a lot of examples for the measurement system in our daily life. For example, the fuel indicator and the speed indicator of in our vehicles, in our cars. So this is a good example of daily life in regarding the measurement system. Okay, and when we are going to the market, so a lot of things, for example, the the weight and the length. Okay, so these are the examples of the daily life for the measurement system. Okay, so this is the block diagram. For example, this is the input, and here is the output, and here is the absorber. Okay, so the input, the true value of the variable, and this is the measurement system, and we get the output of this measurement system. Okay, and we are observing these output value. For example, these are the fuel. Okay, so fuel, when fuel, and this is the measurement system. For example, they gauge it, the level sensor, which are getting the information regarding the level of the fuel. So this is the measurement system. Okay, and this is the display, the LEDs display, or the LCD display. Okay, so we are observing, for example, this is a driver, so the driver is observing the LED, which shows the indication of the fuel and for the fuel level. Okay, so this is the whole diagram of any measurement system. So I have taken example of the fuel in the car. Okay, there are so many examples similar to these as well. Okay, the terminologies. So calibration is a very important term in the instrumentation and measurement. So, as you know that for any instrument, calibration is mandatory. Okay, for example, if we have a thermometer, so this is nothing but a glass tube. Okay, and it is filled with a mercury. So if it is not calibrated, so we cannot be able to measure any temperature. So rather, it is a simple a glass tube for us, and it has no meaning for us. Uh, uh, so uh, so far, as long as it is not calibrated. Okay, so once it is calibrated with the standard. Okay, uh, there are a lot of methods for for calibrating and any instrument. So for example, uh, i I have to placed this thermometer in on a known hot plate. Okay, this is a hot plate, and the value of the temperature for any instant is can be find out by this knob. Okay, so for example, if I rotate the knob to the 5 degrees C, okay, and then I've placed this thermometer over there, and the mercury that will rise to some level. So as I know that I have put this thermometer on a known value of 5 degrees C, so it means this is 5 degrees C. Okay, now I will rotate the knob to, for example, 6 degrees C, then 7, then 8. So similarly, the mercury will rise to the corresponding values. So by this way, I will calibrate the whole thermometer by comparing this with the known temperature values. So this is one of the methods of calibrating any instrument. Okay, so remember, this will be checked many times to by some other hot plate or by some other mean, so that it is verified and authenticated that really it is working properly. Okay, because once it is dispatched to the market, so it will give a correct value uh, in the laboratory or for any observer. Okay, so this is the calibration. Okay, giving the values to any, for example, if I have a clock. Okay, so it has a minute and needle, and the second needle, and the hours needle. Okay, so uh, I will compare, I will calibrate this by comparing it with the known time. Okay, so for example, I have a wristwatch, and at that time, the time at my wristwatch is 12 noon. Okay, so I will move these needles to 12 noon. Okay, and then the time will start. Okay, so after 5 minutes, uh, when in my wristwatch the time is 12:05, so the needle will move somewhere over here. So I will calibrate it by writing 1 over there. Okay, and similarly after 10 minutes, the needle will move somewhere here, so I will write 2 over there, and by this way I will complete the whole calibration process of this clock. Okay, and the second term is test instrumentation. It is a branch of the instrumentation and are most closely associated with the task of gathering the data during various development phases encountered in engineering. That is flight test instrumentation for testing and improving the aircraft. So I have already told you that after the calibration, we have to pass this instrument through a testing phase, so that its calibration is verified many times, and it is error free. Okay, so there is a detailed lecture on the errors of instrumentation as well. You will study it in our upcoming classes. Okay, there are many types of the errors which can be occur in any instrumentation. For example, the systematic error, and the environmental error, the observer error, the theoretical error. Okay, gross error. So these are many types of error which is included in our course, and we will study it in our upcoming classes. Okay, so what I have talking that we have to pass the instrumentation through the testing phase after the calibration. Okay, move on to the next slide. Transducer. It is a very important term for which you have to know about it. The transducer. So a transducer is any device which can convert any form of energy from one to the another. Okay, so there is no specification for the energy, no matter what type of type of energy is transforming, but it is a device to transform one form of the energy to another form. Okay, so input is also the energy, output is also energy, but it is one form and this is another form, and the device which are converting these energies from one form to another form, these are called what? The transducer. So there are so many examples in our daily life. For example, the solar panel. Okay, solar panel is converting the light energy into the electrical energy, so this is a transducer. Similarly, the voltmeter is converting the electrical energy to the mechanical, because the deflection or the movement of the needle, this is the mechanical energy. So for example, the generator is converting the mechanical energy into electrical energy, and the motor is converting the electrical energy into the mechanical energy. So all these are the transducers. Okay, so some of the transducers are electronic transducer. So these are the specific type of transducer in which either the input or the output is in the electrical nature. Either the input is electrical energy or the output is electrical energy. So these type of the transducers are the specific transducers which are termed as electronic transducer. So for example, the generator and the motor. In generator, the output is electrical, and in motor, the input is electrical. So both of these can be termed as the electronic transducers. Okay, now the sensor. The electronic transducer that convert physical quantity into electrical signal. These are actually the sensor. Okay, so any sensor, for example, temperature sensor, pressure sensor, level sensor, so light sensor, heat sensor. So these are actually the sensors which are converting the physical quantity in the electrical form. Okay, so the output indication will be in the form of the electrical. Okay, actuator, the electronic transducer that converts electrical energy into mechanical energy. So example of actuator is a voltmeter, ammeter, and ohm meter, etc., which are converting the electrical energy into the mechanical because of the deflection. Okay, I am talking about the analog voltmeter and the ohm meter or a multimeter, not the digital, because in digital the output is not in the form of the mechanical energy, rather it is also in the electrical format. So it is mandatory for an actuator to have the output in the form of the mechanical energy. So we will discuss more thing about the instrumentation and measurement in our second phase of this lecture. Okay, so stay with us. Thank you.